I think I am audible.
Yes, sir. You are audible.
Okay. So thank you, the chairperson of this session and the organizing committee members. बहुत भल लगिला कि we are doing something about our state. मोर ना हैला आतिश कुमार साहू मीन्स मो इथे नागालैंड रे प्रथम इथे नॉर्थ ईस्ट रे फर्स्ट टाइम एथि पे आसली तो मु जानियार थिला कि जागार से जो आमे जो डर अछि नॉर्थ ईस्ट टा कोन तो मु सेटा छाडी माने जानिया पई ठीक आसली नागालैंड यूनिवर्सिटी जॉइन करली सेटा स्टैटिस्टिक्स डिपार्टमेंट नथिला इकोनॉमिक्स रे जॉइन करिकरी इकोनॉमिक्स ऊपर मु आउथरे पढा पढी करली इकोनॉमिक्स सब्जेक्ट रे मुझे तो पढ़िली देखली कि इकोनॉमिक्स इज अ वेरी इंपोर्टेंट सब्जेक्ट जोटा कि जा ऊपर कि किछि नवा मॉडल बने हो सेते मोटे कोनिक इकोनॉमिक्स रो कांसेप्ट डेवलप करछि धीरे धीरे मु आई विल ब्रिंग इट टू द कांसेप्ट टू दिस हाउस लेटर सम डे तापरे मु 2020 रे एठी जॉइन करली सीयू इंफाल रो एटा कैंपस ता पासीघाट अरुणाचल प्रदेश रे नाउ आज रो सब्जेक्ट हैला रिग्रेशन एनालिसिस जेहेतु मु स्टैटिस्टिक्स एकेडमिशियन मो पई ए सब्जेक्ट रो जो डेटा साइंस जो करेंटली व्हाट इज द डेटा साइंस इज
that can interrupt करती actually even some of our participants actually they are from other background like they are not from Odisha
okay.
so it will be
okay so I will start
good if you can
this is,
yeah
I thought
you can use your English
okay sir okay sure
so most of the time we are also trying to follow a common language
okay very well no problem basically I am an academician means our thought level lies in the theory and how it is to be applied now where to be applied is the job of the entrepreneur or a government or any non-government service sectors so we will start I will share the screen of my today's lecture we'll go one by one I hope it is visible to all of you.
Yes.
I hope it is visible, na?
Yes, sir.
yes
Okay. So before we start this concept of regression, I want you as a participant, all of you, whether we are interested in academic research or application of AIML, because both are in a very, what you say, going towards very different direction. Because if you say data science, the statistics, I teach the subject statistics as a subject of collection of data, summarizing it, analysis and interpretation. That is a statistics. And when you say data science, we say it is about computing, advanced computing, plus to the statistics. Now, this is academic research. Now, under that one, there is a limitation of statistics. The limitation of statistics also we have to remember, where statistics cannot be applied. So, statistics cannot be applied to individual events, but it is for a collective data set. So, what is happening in today's AIML? We are trying to predict a picture like a dog as a dog. So, sometimes it will, our system wins, our system fails. So that is the biggest issue today is we are utilizing the technology of what is the academic of statistics to advance AIML where there is a limitation we are crossing. So I will start with what is regression, but before we should know whether we are into academics or we are into application. So the participants of this AIML summer school should focus on either you should choose academics and research on AIML or application of AIML. You decide first. Research. Why? Because I say this because research require understanding data. Whatever data comes, like many data comes. So you have to understand the data, its distribution first. computing the language proficiency, like computer language proficiencies are there. You should know Python, you should know some MATLAB, some R software. Many softwares are there which are developed for this purpose. Then you have to understand the statistical theory also. Statistical theory means what is the underlying assumption of doing this research. Then you have to also fix the accuracy level. So this category is time consuming process, but it prepares the platform for novel application. So as somebody will say, shortcut is not good. So I will suggest all the participants that not to straight away go to AIML without understanding the basic of academics. Second part is application of AIML. So since most of the participants here are interested in application, so what they require to know? They require to know the business or service model, source of data, APIs, data security, managing resources, adding value at every opportunity. So this needs support of some academician. So I told this one because you have to first classify yourself as an academician or an applicant of the these kind of technologies. So before we start data regression, we should know what is data. So AIML begins with an objective that requires data collection. Whatever AIML is required, whatever we are going to do, that requires data. So data collection is the first primary issue, and types of data, what kind of data you are collecting. And we have to look for the gaining latent information, some information which are hidden. We have to know about that one also. So data are of three types: scalar, nominal, and ordinal. Scalar can be discrete. The scalar data is what? Discrete, like count data. Or can be continuous, like height data. Height, weight, all kind of unit based. So, and the nominal is what? Nominal data means name and categories. Ordinal means order, rank, etc. Remember, AIML directly applying to any kind of data will fail because the underlying distribution don't support the theory, don't support the basic assumption. So all further analysis depends on type of data. So we have to be very careful about what type of data we are taking. Okay, if it is a vision image based data, if it is a sound based data, speech based, or if it's text based, or if it's some digital data, some kind of collected field data, these are all type of data that is to be, their character should be known to you. Okay, actually we say distribution. So distribution should be known to you. Now come to the concept of univariate, bivariate, and multivariate setup. So before we go for this regression analysis, we should know what is univariate. Univariate means when a single variable is under study. Like one example, like household income of, let's say, Bhubaneswar. What is the household income level? Average household income of Bhubaneswar. So that means only one variable is computed or collected. Bivariate data. When we say bivariate data, two variables are required and the relation is of our interest, like household income and household expenditure. That means for a same family, we will ask how much is your income and what is your expenditure, monthly basis. So that means these two are related. We know very well whoever has a larger income will have a larger expenditure. So bivariate data looks for two variables under study and the relationship. Now come to the multivariate data, which is very important for a AIML expert. Multivariate data means more than two variables at a time under study, and its interrelations and dependence model. That means how it is related or depending on each other, like household expenditure, household income, age of the household head, education level, etc. So together, if we take for a Bhubaneswar city, for all this data, we say it is a multivariate data set. So bivariate data analysis. So univariate, I hope I will not discuss. Univariate is already very easy. We normally talk about what is the average, what is the median, mode, what is standard deviation. Those are all exploratory for single variable. Okay, we find out so many we say parameters on it. Standard deviation, like what is the range, etc. But when we say bivariate data analysis, we start with correlation. Correlation is the fundamental part of the basis of going for regression. If you don't have any correlation, you should not go for regression. So correlation analysis, it looks for a single measure. That means some number that gives direction and strength of relation between two variables. So it means when household income, household expenditure, these two variables are under study, we want to get one figure which we can talk about in terms of relation. It describes the relation, one number. So that is called as correlation analysis. So it is like, example is how proficiency in mathematics helps learn physics. Somebody, we say in class 12th class, early days, somebody good in maths, then we say he must be good in physics. So this kind of relation we have to quantify. So that is called as correlation analysis. So it begins with scatter diagram that helps explore relations. Now I will show it in the next slide. Then for quantifying the relation, we have Carl Pearson correlation coefficient R that quantifies the linear relation between two variables. Linear relation means straight line. So this is the fundamental relation that is applied to many of your analysis. But remember, there are some non-linear relation also exist. That also we have to check it out with the scatter diagram before going for regression analysis. Then limit of this R is -1 to +1. So all the correlation coefficient normally lies between -1 to +1. So +1 means perfect positive correlation. That means if the variable 1 is increases by 1 unit, the second variable will also increase by proportionate units. So this way, positive correlation. If it is -1 correlation coefficient, that means if one variable increases by 1 unit, the second variable will decrease by proportional. It will decrease. So if correlation is significant, then regression analysis is useful. Now, what is significance? It is a test of hypothesis. You have to test it by using either t-test or z-test. You have to test it. If the correlation is okay, then only you should go for regression. Now observe the picture. Positive, you will observe that so many dots are there everywhere. What does it indicate, these dots? These dots are nothing but paired observations. Like x-axis is income and y-axis is health index. So that means every dot, let's say if you count the number of dots, it is suppose, let's say 1000 respondents, 1000 observations. So each observation is paired income, health index. This is taken from health.state.mn.us. So they have shown that scattered diagram, and the one single line, straight line, is trying to fit that data, is trying to fit the red line. This straight line, we call it as regression line. Now this line may not be always the true picture. We cannot use the straight line to predict for every single individual event afterwards. We may not be true. So that one we will see as an accuracy later on. And in the first picture, you observe positive correlation, how it looks like, negative correlation, how it looks like, no correlation case, how it looks like, and curvilinear. Now, when such non-linear relation exists, then your straight line doesn't work. So that also should be taken into care before going for any regression analysis. So what is the background of this subject? simple linear regression analysis. The term regression literally means stepping back towards the average. It was first used by British biometrician Sir Francis Galton long back in 1880s. Remember, we are using the same regression analysis for our current AIML. So this limitation exists. We have to agree to it. Regression is not a very good basis for AIML all the time. We should be very careful of applying regression. Okay, like we are using logistic regression all the time. So our accuracy will be hampered if you don't have lot of data to learn. Our training data set, if it is very less, or comparatively, we say, as earlier in the morning session, I was hearing deep learning session. Deep learning does not work. The starting sentence was that way. That means regression line will work only when the distributions are, the data distribution is as per the assumption. Otherwise, it will not work. So this was used by British biometrician Francis Galton long back in 1880s. So statistician and AIML expert, they should come together to find out a middle line, somewhere where regression can be modified or to be adopted in such a way that it is applied by the AIML expert. Now, regression analysis looks for a mathematical function, some formula that relates to variable in such a way that one variable depends on the other variable, which is also called as independent predictor or explanatory variable. So we are looking for a formula. The analysis evaluates how much information is possessed by the independent variable X to predict dependent variable Y. Now, this cause and effect relation, whether it should be known to you or you should test it by some causal test like Granger's test of causality. Statisticians should be there to tell this one whether X is sufficient to predict Y. So academicians are required to understand this prediction part. Now, to example I have shown is to predict household expenditure given household income. So what is the household expenditure if we have one household income value given a model is ready? Okay, so this is one example I have given. Now see the picture here, linear regression between UK and US stock market. Now stock market is a very fast growing. That means there is a very lot of money involved there. And lot of AIML equipments are used there, especially for cryptocurrency. Cryptocurrency forecasting, now people are searching for the best model. They are not getting it because they're all relying upon time series, ARIMA, ARIMAX, or some regression, which has some limitations. So anyhow, you see the correlation when it is a linearly related, whether we, it is just showing correlation of 0.73. See the dots, blue dots are showing the rates, jumps of US and UK markets, pair data. And they are showing some trend is there. Obviously, if UK market goes up, US market goes up. Now, who depends on whom? That is to be tested by some statistical test of hypothesis, not by intuition. Normally, we say if the US government, they increase their Federal Reserve will increase their rates, then the stock market falls. Now, this concept, whether it is affecting UK or UK deciding something, will precede US stocks. So both the way we have to sure which causes whom. Then only regression can be applied. Now here, y-axis is FT, 100 monthly return. That means FT 100 monthly return depends on S&P, Standard and Poor, that one. Their 500 monthly return. So S and P is taken as independent variable and FT is taken as dependent variable. But you should remember that if we change it, correlation will remain same and the chart will differ a little bit. I will show in the next slide. Now the formula is there, the slope, you need not worry about it. You have to see the formula, that is linear line, that is y is equal to 0.6059x plus 000 point decimal 0009. That means there is something called slope mx plus c. Slope is 0.6059 and intercept is 0, almost close to 0. R square is 0.52. This R square is coefficient of determination. This is just a square of 0.73. If you square the 0.73, you get this value. Now, this value will tell you how much information this kind of chart model holds. So we'll discuss later on. Now, what is the theoretical background of simple regression? Regression equation of y on x, that means y depend on x, is given as y is equal to a plus bx plus e. Okay. Y is dependent variable, x is independent variable, a is the intercept, b is the regression coefficient or the slope. A and b are constants and e is error. Now this a and b, small a, small b, these are to be estimated through sample, because we call it as parameter. Parameter means for the whole universe, this a and b represents the relation model parameter. But how to estimate it? Through some sample data. So we will collect 500 observation, 1000 observation, 10,000 observation. These are all sample training data. In data science, it is called as training data. So we take lot of training data to train the model so that our bias is less. That is, the error is less. This error is also assumed to be normally distributed. Okay, and same variance. So this concept, this assumption, I will discuss also afterwards. The level information on y as explained by the model with explanatory variable x is shown by R square. So what is R square? I discussed earlier. It is the information that the model holds for predicting y given a value of x. So limit of R square coefficient of determination is 0 to 1. So that means if you are getting 0, that means 0% information. You have to throw the model. No necessary, not necessary. And if you are having 1, then you are having 100% information of y given a value of x. So our try is, whenever we use AIML, we try to improve the R square to more than 90, 95, 95%. We want to increase it to 0.95, 0.99. So what is the interpretation of simple regression analysis? How to interpret it? Problem today with our fast generation is we apply everything in computer and we don't try to interpret it. We directly accept the result. And that is the fault of maximum regression analysis in today's world. So calculation of R square is important to know how much information on dependent variable is held by the model. So look at the R square value. If it is very high, 0.95, 0.9 and 95 above, then you say that model is working well. Okay. Now, more than that, you should also see the adjusted R square. Adjusted R square is the R square adjusted with the degrees of freedom. So that means when I will discuss that one later on when I talk about multicollinearity and autocorrelation problem of regression. A regression analysis is tested by F-test. So remember, even if your R square is coming 0.95, don't stop there. Go for testing by F-test, ANOVA, for its adoption or no model suitability. I have seen many models which are crossing 0.9, but in ANOVA they fail. So this one is another important vital issue that you have to remember. That means when you say overfitting, the concept of overfitting, that means model is working for trained data, not working for the test data. So that means you have to test it by the ANOVA, whether the regression model is passed by the F-test or not. Okay. Each parameters like intercept and partial regression. Now, this is another big concept. Here, simple regression, we have two parameters, intercept and regression coefficient, A and B, the slope. So A, B are to be tested individually through t-test to know whether the model accuracy depends on that coefficient or not. That means whether we need to keep the intercept or we have to delete the intercept, or we should delete the partial regression coefficient. That means both A and B are relevant or not. That is also to be tested by t-test before we go for the acceptance of the model. Assumptions in linear correlation regression. I wish to I still accept people asking question. Huh? It's okay. You can ask anytime. If you have any doubt, you can straight away put forward your query. I will take it because this concept will gradually go deeper into other issues. See, the assumptions in linear correlation and regression. The first assumption is the set of X and Y are linear in relation. That means when you look at the scatter diagram, have you observed a straight line coming out of it? And whether they are not very far away from the straight line. Second is error of the model is normally distributed. What is error now? Error is the difference of the dot, the Y part of the dot to the straight line. That means vertically up. That means the predicted Y minus the actual Y for each dot. That is called as the bias error. You have to model it. You have to put it into plotting, and you have to check whether it is normal distribution or not by using either PP plot, QQ plot, or some kind of testing. Okay. So error of the model should be normally distributed. Third is no multicollinearity should exist. Multicollinearity means if the set of independent variables, actually this is to be applied for multiple linear regression. Rather, I put it here. But remember that multicollinearity is if you have many independent variables, they should not be related to each other. Okay. Third, the fourth one is error is homoscedastic. That means the variance of the error should be same for all the points, all the variables, all the records. You can imagine that. Error should be homoscedastic. Sigma 1 square, sigma 2 square, all should be equal. No autocorrelation. No autocorrelation for time series. This is autocorrelation is for time series data. The autocorrelation to be tested also by some testing mechanism is there. It is similar to multicollinearity. Okay. The x's are non-random or fixed constant. The independent variables are non-random. At each fixed value of x, the corresponding value of y have a normal distribution about a mean. So this kind of theory are there behind it. You have to check it for every stage. Then only you can apply. Okay. For any given x, the variance of y is same. That is homoscedastic concept. The value of y observed at different levels of x are completely independent. Like records. Same family, you are taking 5 observations. Obviously, all the people will tell the same thing. If you are having a patient, you are collecting information from the patient and relatives of the patient. They are also affected by same disease. You are collecting same information. So that means they are all not independent. They are dependency. So records all should be independent of each other. Now come to the multiple linear regression analysis. Here, when more than one independent variable are utilized to predict one dependent variable, that means many independent variables, x1, x2, x3, x4, x5, many, and it predicts y, single variable y. Then multiple linear regression analysis is applied. So in modern days, MLR is more relevant to you all. The model looks like this way: yj equal to beta naught plus beta 1 x1 plus beta 2 into x2 plus dot 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 plus beta p xp plus eta j. What is j? J is the number of data required to train the model. If you are having, let's say, 10,000 data, so j becomes 10,000. y1, y2, y3, y4, by 10,000. And what is p? Beta 1, beta 2, beta p. This p is the number of variables under study, number of independent variables under study. Like I told, household expenditure, if you want to predict, you have to apply many independent variables like what is the income, what is the age group, what is the education level, which location they are located, all these things. So these are all called as independent variable. Now beta naught, beta 1, beta 2, these are called as partial regression coefficients. And what is eta j? The EJ is the error. Now you are observing EJ. That means for each record, you have an error. That is a sampling error. Each record, this error exists. You cannot exactly predict y, actual y of the first family. Like first family, actual expenditure is 10,000 rupees per month. But by the model prediction, it is giving 9,800. That means what is the error? You will say actual minus predicted. It is 200 rupees. So eta 1 is the 200 rupees. Similarly, you can calculate error for the second, third, fourth. So this error, if you get it after the model is formed, you have to plot it and see the histogram, see the distribution. If it is a normal distribution, then you will understand with mean 0. Remember, it should be normal distribution with mean 0. So that way you can understand that, okay, this model is working well. These betas are unknown, and how this is estimated by the theoretically, it is estimated by ordinary least square technique. Note that all y, x1, x2 are scalar in type. Very important. I have discussed the data type. I told scalar, the starting part. Scalar means numbers. Numbers means if all are discrete type, then it will be disturbing. If all are continuous, then it is better. So continuous type of data are actually the data for which regression is made for. This linear regression, continuous data. If it is a discrete data, we have to look at it. What kind of, whether it forms into any particular discrete, like number of discretion is less, something we have to check it out for that one. If it is a large number, more than 30, we can accept it as continuous and go about it. Okay, or we have to do suitable transformation. Transformation are as normalization. X minus mu by sigma, or square root transformation, or angular transformation, or log transformation. So many of the discrete data or percentage wise, like proportion data is there. Some kind of data X is into proportion data type. Proportion mein hai. So that means that also should be transformed to a suitable, through a suitable transformation. Not always X minus mean by standard deviation. Either you can go for square root, angular, or some logit, probit. These kind of log transformations are required to convert it into normal form. Now, for going for multiple linear regression, you should understand what is correlation matrix. MLR begins with understanding the relationship between each paired variables, that is characters under study. Suppose you are having 10 characters under study. 10 characters means including 1 dependent variable and 9 independent variable. So that means you have to know all the 10 characters interrelationship through correlation matrix. So first you have to develop a correlation matrix. Correlation matrix you observe, this is from www.displayrr.com. You observe there is some election related survey was there. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters under study. Always to vote in election, never to try to evade taxes, always to obey laws, keep watch and action of government. Some political survey was there. So here, this is a 9 by 9 square matrix. 9 by 9. 9 in the y-axis, 9 in the x-axis. All the diagonal elements are 1. Now observe that if we want to know the first correlation, 0.94, always to vote in election, never to try to evade taxes and always vote in election, 0.94. It is a very high correlation. You will be easily accepting it as it is very good for prediction. Let's say their relation is very strong. Whoever don't try to evade taxes, they always go for vote. This kind of concept comes in our mind. Similarly, all other interrelationships you have to observe. Some of the relations will be negative. Some of the relations may be 0. So you have to first check it out so that for prediction of y, the relevant independent variables should be there. That means for predicting of y, I need not take all the 9 variables, all the rest x1, x2. I can drop someone so that the model efficacy will increase. If we don't drop, it will not affect that means it will affect the model performance in the test data. Partial correlation. Now, I showed you the total correlation matrix there. Now there is a concept of partial correlation. So partial correlation is actually the true relation. Something like the total correlation observed in correlation matrix hides many direct and indirect relations. Whatever you are viewing in the correlation matrix is a total correlation. So here many direct and indirect relationships are there, which is hidden there, which means if 2 variables are related, then it may happen that the relation exists due to the effect of third variable. Example, a tall x1, that means a tall plant, a height, is positively related to fruit yield. Since I am a horticulture, I am in horticulture college, fruit science is here taught. So I will discuss in that way. I hope it will be, you can relate it. A tall plant, we can imagine that it will be having lot of fruits. Also, a tall plant is positively related to number of branches. We can imagine if it is a tall plant, number of branches may be also high. This means that number of branches is positively correlated to fruit yield. See the relation now, third relation coming, that if the number of branches is high, then fruit yield will also become high. So this is multicollinearity. So there is no additional information there now. That means if you take x1, x2 and y, all are interrelated. Any 2 can serve the purpose. You can drop the third one. So this third one, you have to imagine which one should be dropped. So this is the job of partial correlation. It helps you identify the variable which is redundant and which can be dropped by step-down regression. So when most of the regression analysis fails because of this reason, that the redundancy of a variable is not identified, or some important variables are not identified and kept in the model. So either you have to be, that means you have to be very careful whether we should go for step up regression or step down regression. Step up means you have to add one variable at a time and see the R square. You have a Y, take X1, fit the model, simple linear regression, see the R square value. Then add X2 to the model and see the R square. It will obviously increase. X3, it will increase. X4, it will increase, but in a shorter pace. You have to go on adding the variable till the R square increases. And here I will ask you to note down that here R square is not that important, but you have to look at the adjusted R square, whether adjusted R square is increasing or not. If the adjusted R square is not increasing and R square is increasing, you can understand that the redundancy of the variable has started. The variable that you are adding after that is redundant. It is no more having any effect on the model. So the rule is to avoid those variables which do not have additional information on dependent variable y in regression by looking at partial correlation values. So partial correlation value will always help you in identifying the right variables to put it into the model. Look at this picture, this data. This is a stock, this is a stock market. No, this is about, there are some month, interest rate, unemployment rate, and stock index price. So stock index price is a dependent variable. It depends on unemployment and interest rate and month. Okay. I think month of investment, I have not written here. This is taken from, I have written up, I think. Whatever. Stock index price depends on these three variables. Now we'll see after you fit it in the regression, some software, whichever, Python or MS Excel or whichever, you will get one formula. Like it is written below, stock index price is equal to 1798.40 plus 345.54 x1 minus 250.1466 into x2. So x1, x2 is this month is not taken. X1, x2 is taken. Okay, that is interest rate and unemployment. So this is an example. Earlier, I have just shown you how to get the result. Here R square is also not shown. I hope I missed it, I think. Anyhow, I have to show you the R square actually here, whether it is working or not. Yeah, I missed it. Come to the nonlinear regression. In statistics, nonlinear regression is a form of regression in which observation data are modeled by a function which is a nonlinear combination of the model parameters. Parameters, there are two types of nonlinearity. One is nonlinear in parameter, that is A and B are nonlinear. That is square root of A, B to the power minus 0.23, something that way. So when the power of A and B are 1 each, we call it as linear in parameter. A to the power 1, B to the power 1. Or beta 0 to the power 1, beta 2 to the power 1. All the power of the partial regression coefficient, it is 1. We call it as linear in parameter. If it is non-linear, then beta has some power which is not 1. Okay. Now there is another one which is non-linear in variables. That is when you have x1 square, x2 cube, that means the independent variables are powered. A1 plus B1 x1 square plus B2 x2 cube. These are called as non-linear in parameter. So when you say non-linear regression, you are actually talking about non-linear in parameter, but not in non-linear in variable. So here you can observe there is one line, curved line in the picture. This is about density with mobility. So mobility equal to 1243 plus 412 into density ln. ln to the power 3. That means some power of the, this is a mod, this is a non-linear in parameter. I think parameter is, let me go to the next slide. Let's see. Here you can understand what is non-linear regression in non-linear in variable. So you see parabolic regression. When you want to fit a parabolic regression, that is a quadratic equation, polynomial, we have studied in algebra, y equal to theta naught plus theta 1 x1 plus theta 2 x1 square. This is a non-linear in variable because here power of thetas are all 1. But the variable x1 and x1 is squared. Similarly, go to the exponential function. The next one is exponential function. Suppose you want to fit a exponential line. Y equal to a into b to the power x. That means the power of b, that means, the variable is standing at the power form. That means it is exponential form. The variable is sitting as exponential. Now, power function, there is other way of exponential is power when this function is represented as y is equal to ax to the power beta. That means the parameter sits at the power of the x. You are estimating beta. Remember what you are estimating here. Here you are estimating capital A and beta. In the exponential function, what you are estimating from the sample data? You are estimating A, B, and C. In the logarithmic function, y is equal to log ax. So log ax, simple log function. So this is your base is a. I should write here a log x something plus b something. However, you can imagine that log function is purely taking a log of x. If y is related to log of x, it's a logarithmic function. What is a logistic regression? So we will discuss logistic regression later on. This is also non-linear regression. Starting with the binary logistic regression. Logistic regression is the basis of most of the neural networks that is happening in the AIML. Logistic regression is a process of modeling the probability of a discrete outcome given an input variable or a set of variables. So what is we are looking? Our answer is probability. In that linear regression, our y was a scalar data. And here logistic regression, our y is a probability. Okay. And it should be binary form. That means 0, 1. That the most common logistic regression models are binary outcome, 0 and 1. Like note that y is a probability of binary outcomes like yes or no, good or bad, 0 or 1, diseased or healthy. This kind of concept, if it is there under study, then that is called as binary logistic. Here, x1, x2, xp are the scalar with discrete or continuous data type. So what is the data type? It is there. Y is binary, but x1 and x up to xp variables, they are scalar. Remember, if y and x both are discrete and like say binary type of or ordinal type, then we cannot use logistic regression. We should go for some other like plum models or probit analysis. That kind of analysis will come. So logistic regression, it is the primary difference between linear regression and logistic regression is that logistic regression range is bounded between 0 and 1. As I told, y is a probability. So it will always lie between
I think we lost.
new startup has a M&E engineer, and CEO make decision to opt a recommendation system. So what by opting a recommendation system, so the website the user will able to get highly personalized and more relevant news articles. So by giving them relevant news and personalized articles, so what will be profit to their website? So it will be going to increase their click-through rates on news website. So by opting recommendation system, user will spend more time on reading more news. So due to which it will affect on web traffic and act as a marketing tool also. So at there we can put some ads and gain profit from it. Okay. So then we will know what is recommendation system. So recommendation system is nothing. It's just algo which will predict user interest and recommend items, relevant items of the user. Think a scenario. If we see news something like cricket, so it must be showing similar news regarding cricket only. So it will be never so regarding politics or something like that. So it will lost interest. So which companies are using recommendation system? Like almost every companies are using recommendation nowadays. So take example of Amazon. They are using recommendation system to sell product. They are also have Amazon Prime, where they're recommending movies to the user. Spotify is there recommending music. Facebook recommend post. Netflix movie. Google also using recommendation system to rank their content while searching. There are many companies also there who are using recommendation system. So in this mini project, what we need to implement in this, okay? So this is the workflow. So let me tell about something. So this will be our data. So in data, we will having news article data and previous transaction history, like browsing history of a person or user. So let me show you the data. You can get the idea of what things are there. So this one is the data of article. You can say it's content data. So there will be ID, category of the content. So it is subcategory, title, and abstract. It's a description, something like that. So we can avoid these things. We can later on we can drop this column. Don't need this. This much is important.
So Sumit, just sorry to interrupt you. So I
Yeah.
think now Dr. Rathisaw is back. So I'll just inform him that we have taken some time for discussing about mini project, and after that again you can continue your session.
Okay. No
Okay,
problem.
okay, thank you.
Okay.
Yeah, we can continue.
So yeah. So this content is for news articles. So this is category, this is description, and this one is title. And another one will be behavior, the transaction data that user created. So in this data, we will have like user ID, time they opt into the website, or and this has the history of the article they clicked or they read. Okay. So this ID are similar to this one you can see, and after that they have all ID. So this has the history which user have or read the data, and this one is the impression. Impression means if some user news channel showing his predicted things. Okay, so which article the user most see? So 0 indicates he have not seen. So there will be one something like this. This one here is one. So he have read this article. So more description you can find on this. It is written like history. I have put on mini project GitHub page, so you can see about this one. What more things are written. Okay. So back to this. So after getting data, we have to get top and review website. So what about the review website? So when user go to the website and model predict and give some predicted news to him. Some news are left, so he did not see it. So this will be showing back to them that predicted news which he have not seen. So next one is content based. So we will show we will show them similar news to them. So if someone is opting for like uh, cricket news, we are going to show cricket news to them. This one is popular news. So popular news, I think you can like uh, know it. If someone going to the news channel, you will get the popular news, which popular news is trending that time. Okay. And these are similar news based on user transaction. So this is depend on history. So history we can know from this one. So user send in this time we transact with this history item. So from this we can get based on history. After that, to make it more personalized, we will use ranking algorithm. So what ranking algorithm will do, when we get news from this all algorithm, it will have to predict like which news user will be more likely to read this. So this how after using this, a user get more personalized news articles. So next, so here is like that. What we going to implement top news at certain time interval. So then we will have top review news, which user have not read. Content-based news, as example, I told you the recommendation regarding tsunami and climate change, and this will be showing similar things like tsunami and climate change. Top end news based on transaction history. The user have a unique trend of reading. Like if someone have trend of reading fast sport news, then political news, then Bollywood news, then other user starts with sport news, then our algorithm must recommend the other political and Bollywood. At last, we will use ranking algorithm for more personalization. So, so this four algorithms, and on the top of that, this a ranking algorithm will be working on. So this much I want to say. Thank you. If any question is any question.
Yeah, thank you, Sambit. So if anybody has any question, you can ask Sambit. And also, I think those are interested to for this particular this mini project. I think already some participants have shown interest, so I have tried to connect them. And if somebody more want to join the team, so you can in Discord channel you can discuss more with the Sambit. But yeah, for now, maybe if you have some question, feel free to ask Sambit.
Thank you, Santipia.
Yeah, if no more question, then we'll hand over to Dr. Atisau, because we have in between there was some issue, and at the end there were one more mini project will be explained by Aditya. Okay, thank you, Sambit.
Thank you.
So now I'll request Dr. Atisau, please continue.
Okay, sir. Okay. Actually, network gone here, so I could not continue that time.
No problem.
Okay. So here, there is a lot of rain in this side. If anybody wants to visit, they can visit. Arunachal Northeast is very heavy rainfall is there. Heavy rainfall all the time. So I will. Shall I share the screen now? Mine. Okay.
Yes.
Okay. Okay. So, so we were here in logistic regression, which is the fundamental basis for neural networks. All deep learning neural networks, they are basically relying on the logistic regression concept. So primary difference between linear regression and logistic regression is that logistic regression range is bounded between 0 and 1, because probability, binary logistic, because it is a probability of natural log of odd ratio P by 1 minus P. P is the probability of success. 1 minus P is the probability of failure. Suppose we want to study a patient having a particular disease, yes or no. If you say yes, that is the probability of yes is P, and if it is no, probability is 1 minus P. The ratio of probability of success to failure, when you take a natural log of it, that is the answer of y. That is y. The y in regression equation, we say y equal to something. So y is here natural log of odd ratio. In addition, as opposed to linear regression, logistic regression does not require a linear relationship between input and output variable. So this was also discussed that when I showed you the scatter diagram, I wanted you to see a straight line. But logistic regression, since it is only two variables, two dependent outcomes, so either it will be yes or no. So here it may not be a straight line. Now this is the picture of a sigmoid logistic regression. Upper side, so many dot, upper dot, let's say it is a yes part. And the lower side, the left side minus part, it is no part. So no and upper side is yes. Very few dots are lying intermediate. So either you have a disease or you don't have a disease. So this way we classify using the model. Before going through logistic regression derivation, let's first define the logit function. Because as I told, being an academician, I always try to get into the base of where it starts from. Logit function, however, I will not bore you by a lot of lectures on this. I will simply define logit function is defined as natural log of the odd, P by 1 minus P. Natural log is, I hope you know, logarithm with base of exponential is called as natural log. A probability of 0.5 corresponds to a logit of 0. So I will term the natural log of odd as logit. Logit of, that means if you say what is the log of 0.5 by 1 minus 0.5. So you will say 0.5 divided by 1 minus 0.5 is 1. So logit of log of 1 is 0. So I say logit of probability of success 0.5 is 0. Okay. Probability smaller than 0.5 correspond to negative logit value. And probability greater than 0.5 have a positive logit value. 0.5, that means when the p value is 0.5, then the logit is 0. When the p value of 0 is less than 0.5, then logit value is negative. That is the lower line, dot, negative side mein ja raha tha, that side. And if you have a logit more than 0.5, that means it will be on the top side, right side, more than that is positive value. So this way you imagine the logit value moving in this way. What is odd? Odd is P by 1 minus P. Logit of P, logit P, that means probability of any logit is natural log of P by 1 minus P. Let's set logit of P to be equal to mx plus b. Now we are trying to fit this logit into linear relation. Linear relation, because I can draw a straight line which passes 0 and touches both the axes, the upper line and the lower line. Imagine it is a straight line, mx plus b. Therefore, logit P is equal to mx plus b, or mx plus b is equal to ln P by 1 minus P, or You can put the natural log in the right side, left side. That is p by 1 minus p is equal to e to the power mx plus b, or capital P. That is the probability of what you are trying to estimate. Probability capital P, probability of success that you are trying to estimate. P is equal to e mx plus b by 1 plus e mx plus b. You do the algebra. You can do it. You can calculate. So now probability of x is equal to 1 by 1 plus e to the power minus mx plus b. This one is called as the logistic regression. 1 by 1 plus e to the power minus mx plus b. Since there is only one, I have written mx plus b. If you are having, let's say, 10x, then it will become m1 x1 plus m2 x2 plus m3 x3 up to m10 x10 plus b. If it is 10 plus. So this is the basic of logistic regression. Multinomial logistic regression. Another case is when you have a many classifications. As I told you, disease or no disease is a 2 classification. If you are having 4 classification like no disease, low disease, moderate and high. 0, 1, 2, 3. This kind of categorization, that is more than 2 classification, then we call it as multinomial. Most of the softmax regression for classification is for multinomial. So multinomial I will not discuss much. It is only talking about more than 2 possible discrete outcomes. Multinomial logistic regression is known by a variety of other names, including polytomous LR, logistic regression, multi-class logistic regression, soft regression, multinomial logic, etc. So when you understand the binary logistic, you can easily get the multinomial. So I am finishing off the regression analysis part. Finally, what is the software that you are required to do the regression analysis? Almost all statistical software provides tools or macros for linear as well as non-linear regression analysis. Almost all gives. MS Excel is good for MLR. Multiple linear regression is good, but needs tweaking in formula for non-linear regression analysis. It is for basic learning. So MS Excel is for basic learning and regression for regression and its interpretation. So those who are beginning this AI/ML application, those who are at the starting part, they should first have their hands-on on this spreadsheet, that is MS Excel. MS Excel is very good statistical software. I will suggest you work on it. Learn the Python libraries. Many libraries are there under Python and R. You can collect and you can run it. However, very good is always go for MS Excel. So I will show MS Excel based here because I think that is the starting part. Python and R have command line. So whereas SPSS, even if you have a SPSS, that also statistical package for social science, they are also good for fittings, which is a menu driven. So you have to only go on clicking. Python and R, you should be knowing the codings and all. So I will start the learning part through a basic demo in MS Excel. I am going to share the screen of that one. MS Excel. If you have any doubt on theory, you can ask it. We can discuss meanwhile. I hope this MS Excel file is visible to all of you.
Yes.
Okay.
Yeah.
Suppose
So if
you are
anybody
given-
has any question, yeah. So I am just requesting if anybody has any question, either you can chat it in the chat. You can paste it.
You can send a chat even. We can look at it. suppose you are given some values, you collected some scalar data. As I told, this is for a scalar value. So this is a 36 data. I'm deleting all so that I can do all for you. So there are 36 paired observations. You can observe that yx. So I have written again y, I'm leaving it. Okay. Y and x paired observation, 36 data each. So I told you to, when you have a multivariate, when you have a bivariate setup, first check out their description, y and x, how it looks like. Okay. So that one you can do in this data menu of MS Excel, data analysis, that is you add in this one. Many of your may not have, you have to install it separately. In data analysis tool pack, you have to first go for the descriptive, which is here. Okay. You have to first know what is the distribution, how it looks like. Y. Let's say I will first see what is Y. So grouped by columns. The labels I have not selected Y, otherwise I can choose the label. Output range. I want to see the results below. Oh, sorry. In the input range it got selected. Labels on. Output range. I want to see here. I will see here only Y. Summary statistics I want. I can also go for the largest confidence level for the mean. That is how it in the plotting part, confidence level for the mean. I can see, and I say okay. So here you will observe that what it comes. It comes this way. The average, the arithmetic is 15. Standard error is 3.12. Standard deviation 18. Sample variance this much. Kurtosis, skewness this much. Now skewness you observe it is coming close to 0. That means when you have a skewness equal to 0, remember that the plotting is symmetric. So that means this is slightly positive skewed, this Y, not purely normal. And kurtosis is minus 1.2. Remember, kurtosis, if it is around 3, I think this value runs from, it is calculated in different way. Normally, the rule is if the kurtosis value is 3, then it is mesocortic and normal. However, it is given minus 1.2. So that means it is not mesocortic. It is a negative, means it is going to platycortic. It is little compressed data. I can plot it also. For that one, you can see range 62. Acha, kurtosis means it is a flattened number. Flattened. Oh, flat ho gaya hai. Now, sum is this much, count is this much. Now, similarly, I can do for X. So, first of all, you have to check how the Y and X are looking like. What is the distribution looks like? If they are not matching, then your prediction may not be good. There should be bivariate, joint bivariate distribution. There should be jointly bivariate distribution. It should be possible. Okay. Now, I will not show the X axis again, descriptive. I will go to scatter chart. So I will select YX. I will go to insert and scatter. So you observe, I drew this scatter. What has happened is it is showing X value as the dependent variable and Y value as the independent variable. And based on this one, that means you can imagine X is lying in the Y axis and Y is lying in the X axis. So this kind of picture is coming. Now, if you click on the layout 3, it will give a straight line. I will make it a little bigger so that you can get it. This is a straight line is coming. Okay. I want to see the function. What is the function of relation? This term is X, Y equal to, I should write X now. It is no more Y. It is X equal to 0.0628y plus 15.578. R square is 0.7274. So this relation is 72% information it is holding. Now this line is called as X on Y. Now if I do Y on X, that means I want to put dependent variable to be predicted. So I will put it in the right side of the X. And then I will do again scatter diagram. I will select, I will go to insert, I will go to scatter. I have selected this one. Now observe here. This plot is not the same as this one. So X and Y plottings are different. X on Y and Y on X are different. Now here, if you try to put a line and you want to know their function. So you observe this one. This is Y equal to 11.584 X minus 148.84. That is intercept. And R square is remains same. That means the prediction of Y with given X is same as X with Y. X for Y. So this shows that you should be very sure which is dependent variable, which is independent variable. Now come to the interpretation, whether 72 is correct or not, whether we should accept the model or reject it. So for that one, you should not rely just on R square. You should go for testing it. As I told you, have to know, test it. How to test it? You go to the data analysis, and then regression. In the R, it is regression. Go to regression. What is input? Input Y. So input Y is this one. It is overlapping. Anyhow, but Y is selected. And what is my X? That is independent variable. So independent variable is this set. Labels I have not selected. Constant means intercept. You want to take the intercept or not? You will say no. I will not check it on. Confidence level 95%. That means your type 1 error probability is restricted to 5%. So 95% confidence. If you want to increase it, you want higher accuracy, you can click on it and you put it as 99. I want to see with 99% accuracy whether this model is accepted or not. Okay, the confidence. I want to have a 99% confidence on this model. That model will work. So I set it as 99. So this setting you have to do first. If you are relaxed with your, as I said, if you are interested in application, you want to modify the precision level, you can put it as 90, 80, so that your model will work and people will accept it. If you want to have a very strict towards precision, accuracy, then you have to increase the confidence to higher level. Okay. So this is up to you. Output range. Click on this one and select the region below. I have selected L31. Now residual. If you want to look at the plotting, you can go on clicking. Okay. You want to see the residual. What is the error vector looks like? You want to see the plot of normal probability. You can go on clicking and you will see the plottings. So I'll just say yes. So I'm deleting this one so that you can. Okay. You observe the analysis is out. Whether the regression is to be accepted or not. The model is relevant or not. That is now out. The first one, it says multiple R, multiple correlation. That is the correlation only. It is 0.85. 85% correlation is good one. R square 72%, information hold. Adjusted R square 71%. That means working well. Standard error 9.9. Remember, standard error, if it is very less, then your model is very good. Okay. ANOVA. When you do F test, regression, 1 degrees of freedom, residual 34, total 35 degrees. Now here you have to see the F ratio, and this one, significance, this one, the last column. Last column is the p-value, that is 4e minus 11. You can imagine this as 4 into 10 to the power minus 11. That is 0.0000, 10 zeros, then 11. 4 into 10 to the power, that one, 0.444, 0.0044. So it is very small. It is much smaller than 0.01. We kept 99% confidence. That means 0.01 was our probability level for which we are testing. So still at this point, this is significant. So we will say highly significant. Highly significant means this model is accepted. You can use it for prediction. So when you take it, then this regression model will work. Okay. So here the intercept is already shown in the picture, 148. Yes, and the beta coefficient is 11.58. I was talking about each individual intercept and beta coefficient should be tested by t-test. So here the third variable, third column shows t-statistic, minus 5.344, 9.52414 beta. So this is the t-statistic. Now what is the p-value? Whether we should accept it or not. It says yes, accept it. Because both the p-value are less than 0.01, e minus 0.6, e minus 11. So that means model must contain 148, minus 148, and must contain 11.58. Then only you can predict it. Now, after you accept the model, then for the training data, your predicted y. So I will take this one to the actual y. You can see the difference. After we fit it, I'll paste it here. You see this predicted y, actual y. This one is called as actual y from your training data. Actual y. Actual y was 95, but prediction was 110. So whether we can call it as or not, that is the important thing. Actual was 109, prediction was 120. 133 was predicted as 130. So similarly, all the actual and actual y were predicted by the model and shown. And the residual is the error vector. That is the difference between predicted and actual. This is nothing but the difference. Okay. So this difference, maybe some for single data it is not working well. For the overall collection of the data, this model is working well. As I told initially, that statistics has a limitation that it don't work for individual events, for which we are observing that when we try to classify a car as a car may not always hold true. But for a collective group of cars, like 100 cars, it will predict with 99% confidence. It will predict that most of them are cars. So this is a collective subject. It has very, that means it is limited to individual events. It cannot be applied so easily. So here on an overall picture, this model is working. So this is all about simple linear regression. Now come to the, let's say MLR. MLR is also similar. I will remove the colors. MLR, you observe y is given, x1, x2, x3, x4, x5 are given as another independent variable set. When I use the same data analysis concept, that tool pack, I will get this summary output. All summary outputs I will get. You have to check out the R-square, multiple correlation value. Adjusted R-square, you observe, it goes down. So So you have to be careful about looking at the adjusted R-square values. Now regression, it is now the p-value in the ANOVA table, the p-value is 0.07. Now you have to observe now whether the regression model can be accepted or not. With 99% confidence, you will say no, it cannot be accepted. This model fails now for prediction. So if it would have been accepted, then you should have gone for this coefficient, standard error, and acceptance of each coefficient, like by using the p-value. So this is a scientific way of approaching a regression analysis. What I'm trying to show is, do not just put buttons on your clicks on the buttons, some macros, and some results will come out. That way you will get into other way. Approach in a scientific way so that you can rely on your analysis. You can rely on your model. You can put it to your working mode. Now come to the suppose quadratic model. Quadratic model, if you want to have a non-linear model, then let's say this is the data set and you want to put it into the quadratic form. So I have tried to do it individually, but you need not do. What you have to do is do the scatter diagram, take a straight line and go to this design trend line. Like or you can just right click on the line, format trend line. If you get this trend line options, then here exponential fitting is also there, linear fitting is also there, logarithmic, polynomial with order 2, order 3, order 4, many are there. You can go on fitting. You observe, I will, when I do, it will automatically change. Suppose I click exponential. So R square is 0.972, very high. That means this fit is 97% information it holds. When I say linear, it is 93% it is holding. When I say logarithmic, it is showing 75%. When I say polynomial of 2, quadratic, it is 99%. Now when I try to fit with cubic, it is 99.11. It is still higher. This is called as overfitting. Overfitting. This is working well on the trained data now. See, you see when I increase the order to 4, it is now overfitting, 0.9928, still increasing. When I increase to 5, 9976. You see the picture, how it is coming? So this, you can go on playing with the data and know where to stop, where the overfitting starts, where the bias is low and the variance is low. You have to know the concept. So that way you can get the real model. Okay. So you can also try with the power function. Like it is also giving 98.27%. Then moving average, like ARIMA models are there, that is auto-regressive. This is simple moving average of period 2, period 3. You can go on trying all this. Okay. So I have shown you how to try MS Excel for your basic fitting for learning, initial learning. For higher and large number of data, you can still play around. If you have around 10,000 data, still MS Excel can hold. It's no issue. But these are for a learning, you should take a smaller 1,000 data and try. Okay. Coming to the logistic regression, last part of my my lecture. Logistic regression is, as I told, when you have a binary logistic, your data looks like this one. Data will look like this one. Y is 0, 1, 0, 1, 1, 0, 0, 1, like this, 0 or 1. And your x1, x2, x3 will be scalar with numbers. Here numbers are discrete and small. That's why the results may not be so good. But if it is a continuous data, then your prediction of Y will be better. Since I have taken this one for example, I am not worrying about the precision level or the loss. Now, how to do it in MS Excel? First, calculate the logic. As I told you, logic is you have to Acha, before you go for the logic, first define this one. You observe below, this is called as beta 0, beta 1, beta 2, beta 3. Because beta 0 is intercept, beta 1, beta 2, B3 are the coefficients of x1, x2, x3. Recall that I'm trying to make it linear, straight line. Now, give them some coefficient, initiation. Normally, these initiations are, actually we are using iterative process. These initiations are normally taken after multiple linear regression coefficients. Those regression coefficients should come here. So I should write here, note that I have taken all 0.001. But what you have to do is take coefficients from MLR analysis for initiation of logistic regression. Initiating logistic regression analysis. So that way you can faster achieve your logistic regression. Okay. So I have taken a general number like 0.001. Okay. So now you have to prepare the logic. What is logic? It is beta 0 plus B1 x1 plus B2 x2 plus B3 x3. That one. As I told, P by 1 minus P equal to all those. So that is logic. E to the power logic. That means you have to exponentially power it up. E to the power all those values. Drag it down. I hope you know this dragging concept. Now, after the logic is there, probability you have to do. Probability you have to find out by writing 1 by 1 plus e to the power logic. Now here, one of the issue is where probability is 1 by p for the failure. Log likelihood means likelihood. Now you have to add it up. You take for the all the records, then you add it up. It is coming as minus 8.30. Now you have to use data analysis toolpath solver. Solver you have to use. You have to set the objective. You have to click on this 8 point. That means the sum of the all log likelihood. You have to click on it, and you make as maximize it by changing the variable. This variable you have to set it to this coefficient beta 1, beta 0, beta B1, B2, B3. The coefficients you have to select it, and then here make unconstrained variables non-negative. You have to off it, and then solving method is GRG non-linear. Okay, then you solve it. You click the solve. What happens is it will solve you, and it will give you the coefficient. It has changed the coefficient. You observe the sum of the log likelihood is also maximized. It is minus 5.94 because you are maximizing it. Okay, and your coefficients are achieved. Now here you can also check for the sensitivity of it and the limits of it. I will not discuss all this in this lecture because already time is passing by. So I am keeping it up to this. I am wrapping up this demo session here only. If you have any query, please feel to ask. No problem.
Yeah, thank you, sir. But, it's
Thank you, sir. Thank you.
It's very interesting talk, although it's a quite mathematical things, but yeah, it is really interesting to know about the data
Basic
analysis part.
regression one has to learn, sir.
Yeah,
Otherwise,
because that
we
is,
cannot apply directly.
yeah, that is quite important for machine learning. Even at the end, when we start, people start using machine learning and artificial intelligence. It's a, I used to tell that it is nothing but some vector operations. If you look into this deep learning. So yeah, so now I think many participants have left and some are there. So maybe I will request if anybody has any question, you can chat it, or or if you want, you can also contact later.
Even you
It's
can
not
ask me
a problem.
afterwards also. It's okay. You
Yeah,
can
no
contact
problem.
afterwards. No problem.
Yeah.
Sir, we will share all our email IDs with the group so that everybody can chat with each other. That is the best way.
Yeah, sure. Yeah, that will be really good. And also we'll share your PPTs.
PPTs, yes, PPTs, sorry, PPTs.
Yeah,
Okay,
we can share your, already the PDF format, we'll share the PDF format, at least somebody can go through it. So if, and about the last project presentation, so maybe I think now very few people are there, so maybe they can contact Aditya Kumar through Discord channel to get more details about it. And also here in the subsequent presentation, he will explain in more details because he needs some time. So now I think we have very few participants, so we can postpone that.
Okay.
And at the end, so at the end, I'll again thanks to sir to accept our invitation and prepare the materials and providing a lecture session. And I think it is a really informative one.
Sir, there is no question in chat box.
Okay, yeah, thank you. So maybe if there is no more question, then we can end the session here. So thank you. Yeah, so I'd like to thanks to all, to the session chairs and Santanu Abu. So maybe we can end the session here.
Thank you. Next, we'll resume our next part will be next Saturday. That is 25th. So and to have a note of that.
Yeah. And meanwhile, I think those are already some participants have sent mail and already we have added it to the channel, so they can continue discussing with the mentors and carry out the exercise.
Thank you, sir.
Thank you. Bye.